Okay, so this is a little lesson for my applied math students, my grade 11 applied students. And it's kind of a supplement to 7.6. And here we go. And we'll call it, what do I have here? There we go. We'll call this 7.6 solving for x-intercepts in factored, oh, sorry. No, not in factored, sorry. In vertex form. Now recall, if you go back to I think it was 7.4, that if you are in this form, or no, sorry, this was 7.5. If you're in this form, your x-intercepts.
Are we writing this down?
Yeah. Are x1 and x2, right? That's what factored form is. Factored form tells you what the x-intercepts are. And if you were in the form that we started the unit with, so recall also that if we were in standard form, you can try factoring and solving for x.
Mr. Keller, this isn't in the booklet.
Yeah, I know. That's why we're writing it down.
Oh, okay.
Yeah. Sorry, did I not make that clear? That we're just doing a quick little lesson, kind of additional to what the 7.6 is about. Sorry, my bad. So you can try factoring and solving for x when y is equal to 0. Because remember, that's what x-intercepts are, right? X-intercepts happen when y is 0. So for example, an example of one that we've done already, say that you had the parabola y equals x squared plus 5x plus 6. And I said to you, okay, well, what do I know? Remember, standard form only tells me one thing. Well, it tells me two things, because the a value is 1, so I know what the shape is, and I know that it opens upwards. But the only other thing it tells me besides a is that the 6 is the y-intercept, right? That's what it tells me. So I only know one point here, the y-intercept. If I wanted the x-intercepts from this, I let y be 0, and I factor this. Okay, that's an easy one. What two numbers times to make 6 and add to make 5?
5 and 1.
5 times 1 is not 6.
Oh, so wait, no. 2 and 3.
That's the ones. Plus 2, plus 3. So now we use the logic, okay, this number times this number is 0. What would make this a 0 if x was negative 2? What would make this number a 0 if x was negative 3? So I know that my x-intercepts are negative 2 and negative 3. And of course, Desmos backs me up on that. If I were to open up Desmos and say, okay, let's get rid of all this stuff and go back to home and say y equals x squared plus 5x plus 6. Oh, wait, why is that not working? Oh, there we go, because I didn't click on it. Y equals x squared plus 5x plus 6. There we go. X-intercept negative 3, x-intercept negative 2. So, yep, that works. Now, what if I had standard form and it doesn't factor? Not every trinomial factors. You learned that in grade 10 as well. Well, actually, that'll be tomorrow's lesson. How do we deal with when we're in standard form and we want x-intercepts, but it doesn't factor? We'll use something called the quadratic formula. That's back in the booklet. So we're back to the booklet tomorrow. Okay, for today, though, In vertex form, you have, of course, for example, let's say we had y is equal to negative 2 times x minus 3 squared plus 18. Where does that cross the x-axis? What are its x-intercepts? Well, where do you know x-intercepts happen? X-intercepts occur when y equals 0. So set y to 0, and now do you see what I mean when I said today's lesson was basically that stuff that we did in a couple of the homework questions? I need to solve for that x. Right now it's stuck in the middle of all this algebra. So let's try it. What's the first thing I have to do? Well, I have to do the opposite of all the things that are happening to the x. So x is being, in this equation, subtracted by 3, right? That's the first thing that happens to it. Then it's being squared. So step 1, step 2. Step 3, it's being multiplied by negative 2. And then step 4, it's being added to 18. To undo those steps, what's the first thing you would do? Go to the bottom. What's the opposite of adding 18? Subtract 18. What's the opposite of multiplying by negative 2? Divide by negative 2. What's the opposite of square? Square rooting. I'll just use the symbol. It's less work, less writing. And finally, what's the opposite of subtracting by 3? Add 3. So these are the steps that I have to do to my question. So let's try it. Subtract both sides by 18. There we go. Done. Right? It cancels. Some people actually like to show that. Optional. If you like showing that, go right ahead. I don't need to see it. You're in grade 11, not grade 9. Actually, even my grade 9s, I wouldn't make them show me that. Certainly when I teach algebra to grade 8ers, I make them write that they're doing that on both sides. Okay, so now I have that. Now I'm going to divide both sides of the equation by negative 2. Again, I don't need to see that you did that. I mean, I can see that you did that when you write this step. But if it helps you to understand what's happening, again, optionally, you can divide by negative 2 like that. Now, again, I don't necessarily need to see this, but you're going to square root both sides of the equation. So some people would say square root like so, square root like so. But one thing you should do here is put plus or minus on it, so that on the next step you remember, oh yeah, the square root of 9 here could be positive or negative 3. And square root just cancels the square. I add 3 to both sides. And there's my 2 answers. Therefore, my x-intercepts are 3 plus 3 and 3 minus 3. I'll give you a sec to catch up to me. I know I was going kind of fast. And then we'll just double check it on Desmos. Okay, let's double check it. So let's see. So it was minus 2. Okay, so let's make that one go away. So y is equal to minus 2 times, open a bracket, x minus 3, close brackets, squared, plus 18. And let's make that fit in the screen. There we go. And there we go. X-intercept is 0. X-intercept is 6. So like I said, that's about the most algebra intensive thing you have to be able to do in this course. All right, your turn. See if you can do this one without me. Example 2. I have a parabola with an a value of 3, an h value of -2, and a k value of -3. Find me its x-intercepts. Okay, so I'll give you a minute. I'll pause the video. People at home, pause the video and give it a try. Okay, we're back. So, step 1 is, of course, x-intercepts happen when y is 0. So I have to make the y 0. Set the y to 0. All right, undo minusing 3. So I plus 3 to both sides. Undo timesing by 3. So I divide 3 on both sides. Square root both sides. What number times itself is 1? It could be 1 or -1. So my answer is -2 plus or minus 1. So my 2 x-intercepts, -2 minus 1, which is -3, and -2 plus 1, which is -1. I'll never take away your regular calculator, right? So there are things that, you know, like somebody asked earlier this class, it's like, hey, do we get to use Desmos for everything in this chapter? No, there'll be a few questions, and a question like this would be one of them, where I'd want to see that you can do this without Desmos. But I won't take away like an ordinary graphing calculator, or standard calculator, not a graphing calculator. So that means that we might have questions where the numbers don't work out this pretty. I don't know if you've noticed this or not, but so far, every single one of the numbers, once you get to this step, have been perfect squares. What if, and this kind of gets to the question we had a minute ago, do you ever want us to leave it as plus or minus something? It depends. Let's look at this one. This one actually looks simpler. It's got a 1 in front of it, or a -1 in front of it. But let's run through the steps. Step 1, how do you find x-intercepts? Oh yeah, you make y 0. All right, what's happening to x? It's being added to 5 squared times by -1 and added to 7. So step 1 is to minus 7. Step 2 is to divide both sides by -1. And now here's where the problem is. What kind of number do you get when you square root 7? Begins with an I.
Integer.
Nope. That's the kind of almost the opposite of what it is.
Imaginary number.
No, it's not imaginary.
Irrational?
Irrational. That's the word we're looking for. When you try to square root 7, of course, you get, well, let's try to square root 7. Let's get a calculator happening. There we go. When we try to square root 7, you get an answer that, now this calculator only gives me, what is it, 10 digits? If I showed you 1 billion digits, you would never find a repeating pattern. So unlike, say, a number like 1/3, which is rational, I can show you every decimal that this has. Even though the decimal's gone forever, it repeats. Even 1/6, no problem, it's 0.1 and then 6 repeating. Even 7/11 is what is that one? 0.63 repeating. So it's 636363. If it's a fraction, I can make a decimal where I can show you all of the digits. I might have to use a little symbol that tells you that they repeat, but I can show you all the digits. When I square root 7, I can't show you all the digits because there's no repeating pattern. It's random digits forever. So a lot of times a book will say, give us an exact answer. So my exact answer would be -5 from both sides and you'd stop here. And I think this, the question that I had earlier, I think this is what you meant. Do you ever want us to just leave it as plus or minus something? Yes, maybe, if it asks for an exact answer. But this is an applied course. Usually we're doing this stuff because we're going to solve a problem, like the one we did with the volleyball players and stuff like that. So we would probably want rounded decimal answers. So what is -5 plus the square root of 7? Where'd my calculator go? So what is -5 plus the square root of 7? So -2. I'll use two decimals. -2.35 is one of my answers. And what is -5 minus the square root of 7? So -5 minus the square root of 7. -7.65. And there we have it. There's our two answers. Those are our two x-intercepts. And if you were to graph, again, using Desmos, so let's check this out on Desmos. So again, I should maybe say if that's the exact answer, this is of course rounded. And if I were to kind of show you on Desmos, I think Desmos does 2 decimal places, doesn't it? Go home. And what was this again? This was y equals, equals negative, open a bracket, x plus 5, close brackets, squared, and then plus 7. And okay, let's see, what were my estimates again? 2.35 and 7.65? 7.64. Oh, look at that, they gave you a 3rd decimal place. And there we go, 3 decimal places. But we got it. Okay, one last example. Okay, let's start with the steps. Step 1, y is 0. Step 2, -6 from both sides. Step 3, divide by 2. Anybody see a problem? What's my next step again? Oh yeah, I got to square root both sides. What's the square root of -3? What number times itself makes -3? Guess what? There is no number that does that. No real answer. What is that telling us? What is that telling us about this parabola? Any ideas?
Just a guess, it's not a parabola. It doesn't
Nope.
make a parabola.
No, it is a parabola. It's an x squared. All x squareds make a parabola.
It doesn't have an x-intercept.
That's it. There are no x-intercepts. And you kind of know that just looking at it, right? Because the vertex is -3, 6, and that means the vertex is 3 over and 6 up. And then a is positive. What do you know about all parabolas that have a positive a? They open upwards. So it should make logical sense to you that there's no x-intercepts when your algebra tries to square root negatives, because you can't square root negatives in real numbers. So that's it. So what I've told you to do, now again, this is a little past the textbook. Notice that we hit problems in the textbook that assumed we could do this, but it doesn't actually have questions that just do this. So what I've done is I go back to the homework, and I said, okay, so for today's homework, if there's still people working on these problems and you still need a little bit of time, you can still work on those. But here's my homework for this. Go back to number 1 and number 2 in this assignment and see if you can solve for the x-intercepts, and then check your answers with Desmos. So if you look again at, say, number 1 here, Some of these didn't have x-intercepts, right? Same thing with number 2. Some of these didn't have x-intercepts. So for all of these, set these to 0, and then solve for your x, and then graph them on Desmos and check if you did it. So that's basically it for today's homework. Tomorrow we're going to do a new lesson, different stuff. We're going to learn the quadratic formula. So we'll do that tomorrow. And all right, it's lunchtime.